The liquid water on Earth's surface is all linked through the water cycle, but most of it is actually linked via streams and rivers as well. The rivers and streams that run into the same body of water, whether it be a large river or stream, or a pond, lake, or the ocean, are together called a river system, with these small rivers contributing water to the larger body being called tributaries. Precipitation that falls on land can also find its way into the river system, though. So the land surrounding water to the river system must also be considered. These lands are called watersheds. Watersheds are some of the most protected lands on the planet because any pollutants that fall there tend to find their way into the river system. The path that a particular stream follows is called a channel. How a particular channel looks depends on how the river or stream is eroding the land around it, which depends on the gradient of the stream, its discharge, and its load. Its gradient refers to how steep the land through which the river is flowing is, which makes the water flow faster or slower. The discharge describes how much water is in the stream, which depends on the amount of water in the area and on the river or stream's tributaries. Finally, load describes how much sediment and rock the stream carries. The faster a stream moves and the more water it carries, so the steepest gradient and the largest discharge, the larger its load can be, and the more erosive the stream can be. Depending on how these factors interact, a river could either be narrow and deep, or wide and shallow. Properties of the stream, such as its gradient, discharge, and load, coupled with the properties of the rock around it, decide how much the stream will weather and erode the land, which in turn decides how the stream will look. The appearance of a stream is described as being either youthful, mature, old, or rejuvenated based on the interactions of these properties. Though the names seem to indicate the age of the river, and though the age of the river does sometimes influence how much it has been able to erode the land around it, they only refer to the appearance of the river or stream, not its actual age, relative to other rivers. Eventually, a river or stream slows down and its load is deposited somewhere. The different types of deposits are characterized by where they are relative to the body of water. A slow point in a river, where heavier sediment tends to fall out and settle, is called a placer deposit. These are the locations where people panning for gold tend to gather. Another type of deposit appears when a river or stream runs into a larger body of water, such as a lake or the ocean. There, it slows down, spreads out, and floods some of the surrounding area, depositing a lot of its load. These areas are called deltas. Many of the earliest civilizations formed around these areas because these deposits improve the fertility of the soil. When a river rises because its discharge suddenly increases and it unexpectedly floods the surrounding area, it can also leave behind some of its load. These areas are called floodplains. Again, these areas can be very fertile because of these deposits, but the actual floods can be very destructive. If a river or stream slows down because its gradient suddenly decreased, meaning that it entered a flat area of land, it can temporarily flood the area and leave behind a deposit called an alluvial fan. Often, temporary streams that appear during heavy rains leave behind this type of deposit. A lot of Earth's water is found underground, called groundwater. Any water that percolates or infiltrates the soil becomes part of the groundwater, whether it sticks to soil particles or continues downward and joins an underground body of water. If you have ever dug a hole at the beach, you may have noticed that eventually you reach a point where the hole fills with water. When this happens, you have reached the water table for that area. This is the boundary between soil that is saturated with water and soil that is unsaturated and could still absorb more water. In some places, this boundary is within inches of the surface. In others, is feet or meters down. In some areas, the soil is so dry that there is no boundary. The basic idea behind a well is that it provides you with access to earth beneath the water table and, resultantly, water. Layers of rock that allow water to move through them underground are called aquifers. There is rock present, but these can be thought of as underground bodies of water. The best aquifers are made up of porous, permeable rock, meaning that they have space between the individual particles of rock and allow movement. Water simply being able to move through an aquifer isn't enough, though. The water filling an aquifer comes from precipitation that infiltrates through the soil. So if the soil is too packed and becomes impermeable, aquifers cannot recharge. Much of the water used in the Great Plains is drawn from such aquifers. Groundwater carries with it any pollutants or chemicals picked up from the rock particles through which it flows, meaning that anything dumped on the ground or exuded by a weathering rock enters the groundwater. This increases the weathering ability of groundwater. When especially acidic groundwater contacts soft rock, such as limestone, it can weather the area underground extensively, enough so that even slow-moving underground streams can erode away the sediment. This process can lead to the creation of small hollows underground, or even massive underground caverns. If these hollows collapse, a sinkhole appears at the surface of the earth. We've discussed fresh water found in rivers, streams, underground, in ice, lakes, and ponds, but there's less fresh water available to us than you probably think. Of all the water on Earth, only 2.5% is actually fresh water. Of that 2.5%, 68.6% is frozen ice caps or glaciers and is unavailable to us. 31.1% of the fresh water is groundwater, some of which we can access, some we can't, and some is too acidic or polluted to use. Only 1.3 of the 2.5% of Earth's water that is fresh is actually above the surface of the Earth, and only 20.6% of that, 1.3%, is in rivers, lakes, and streams. The rest is atmospheric vapor. When how little of the Earth's water is actually usable for drinking and agriculture, and how little of that water is actually accessible, protecting it becomes increasingly valuable. Amounts of the water on Earth is actually safe to drink as it is, and we have to share that water with all the living things on the planet. Pollution at the chemical level, not just trash floating around oceans, is a major issue. Most pollution comes from multiple sources, so solving pollution issues usually requires policy changes rather than simply cleaning a single point problem. For humans, most of our water is cleaned at sewage and water treatment plants. Water from anywhere else is usually too dangerous to drink. There are natural systems that can help clean water, though. Forests, because of the abundance of thick plant roots and complex soil horizons, tend to draw out contaminants as water percolates through them and into groundwater. For this reason, the forests surrounding reservoirs are usually protected because they limit the amount of cleaning that the water treatment plants associated with the reservoirs actually need to do themselves.